So a group of n couples is going to see a movie, and a couple is two people, right? So n couples are going to see the movie, n pairs. The seats in each row of the theater is greater than 2n, so that tells us that each row would hold all of the people, because if there are n couples, that means there are 2n people, and the seats in each row of the theater hold more than 2n, so they could all fit in one row, but we don't know if they're going to. If the group decides to sit all in the same row, okay, so they'll all fit, and each couple is indifferent to empty seats, and each couple has to sit together, how many seating arrangements are possible? So in order to solve for this, basically we need to know two things. We need to know the number of couples, and the number of seats that they're occupying. Because all we know is that the rows in the seat are greater than the number of people. We don't know how many seats there actually are. Statement 1 tells us n equals 5, so there are 5 couples, but we don't know anything about number of seats. That can't be sufficient. It's not A and it's not D. Statement 2 tells us that the group will all sit next to one another, starting with the first seat in the row. This does help because it means that basically, you're going to be 3, 4, 5, 6, 7, 8, 9, 10. You'll have all 10 people in a row, and it doesn't even matter how many empty seats. This could be in a stadium where there's 100 empty seats to their right or whatever. Those don't matter. We are fitting, 5 couples in in all their various orders in 10 seats. But we don't know how many couples there are, actually, from statement 2 alone, so that can't be sufficient. Even in conjunction, are these enough? So if we look at the two together, we do know that we are fitting in 5 couples in 10 seats. And even if you don't know a formula for that off the top of your head, you know that if you were given enough time, you could figure it all out. And so clearly the two statements together are sufficient. The number ends up, of course, being quite large, because not only can you figure out, well, 5, it's actually 5 factorial, right? 5 times 4 times 3 times 2 times 1. You end up with 120 ways for the different couples to be ordered. But each of those couples could in turn be, person 1 then person 2, or person 2 then person 1, which means you have to take 120 and double it 5 times. So it ends up being a very big number that you don't have to figure out on data sufficiency. So answer choice C, both together.